Welcome to the Accelerate America podcast, brought to you by Emerson. My name is Michael Gary. I'm the editor of Accelerate America. I'm joined by my colleague in Portland, Oregon, Derek Hamilton. Hi, Derek.
Hi, Michael. How are you today?
Excellent. In this month's Accelerate America podcast, we will discuss some key articles from the January 2018 edition of the magazine, which is available at acceleratena.com. Print copies will be mailed to subscribers and distributed at the Hr Expo in Chicago next week. Hr Expo will be one of our topics of discussion. We'll also talk about Derek's opinion piece and the 2018 predictions by industry stakeholders. We'll also take a look at next week's Hr Expo and finish with a chat about our cover story on CO2 heat pump water heaters. We'll also hear from Charlie Rogers of the City of Seattle's Office of Housing, which is behind the installation of these water heaters at low-income apartments in Seattle. So we'll start off talking about the excellent opinion piece that Derek, who is our Vice President of Business Development and Technical Editor of Accelerate America, great article he wrote called A Tale of Two Sectors. By that he means that spending on refrigeration equipment by food retailers dropped last year, while the industrial refrigeration market did very well. In both sectors, though, the technology behind natural refrigerant systems continues to advance. So, Derek, let's talk about the reasons for this disparity.
Yeah, thanks, Michael. What I've done here with this short article is highlight a few trends that we've seen throughout 2017. And of course, at Sheco, we keep an eye on the market around the world. And I wanted to speak here specifically to some trends that we're seeing in the US market. Now, looking at food retail, we have heard from a lot of our partners that spending on food retail refrigeration equipment was slightly down in 2017, and we do see a number of reasons for that. The first thing, which I haven't really spoken to in the article, is the fact that there has been a trend in the food retail industry in the US to move towards a lot of more smaller format stores. And of course, with the smaller format stores, you have some changes in system architecture. And the change to the smaller format stores is, of course, driven by the needs of the consumer and the way that the market for food retail is changing. Now, the thing I have spoken to in this article was something that made the headlines in the latter part of the year, and that was the purchase, Amazon's purchase of Whole Foods Market. And what we have been seeing and hearing is that this purchase has really made the food retail industry sit up and take note. I think such a big company as Amazon taking an interest in food retail and purchasing a company like Whole Foods Market does throw some uncertainty into the mix, and it does leave food retailers wondering how much of their business may be driven by online sales, or perhaps some version of online selling, such as click and collect. So I do think that this purchase, the acquisition, has really put some uncertainty in the minds of food retailers, and that, combined with the changing way in which people shop, and this really is leading to people holding back on their infrastructure spending, and of course that is feeding through into the refrigeration equipment part of that.
Right. Yeah, it's complicated. You also talked about the strong economy, meaning more people eating out in restaurants maybe and spending less in supermarkets.
That's right, Michael. The economy has been very strong, and we know that unemployment in the US is at the lowest level it's been for nearly 20 years. So that also is contributing to a very strong economy. Now, some people might be surprised that in such strong economic times, that food retailers are decreasing their infrastructure spending. But actually, what I've proposed here is that the reason could be that during this period of the economy being strong and unemployment being low, that we may be seeing less spending on food retail because people have more disposable income and are deciding to eat out a little bit more. So that's one of the reasons I've proposed why we might be seeing this decrease in food retail infrastructure spending.
Right. And in industrial, one of the trends we're seeing that may be driving some of the spending is low charge ammonia technology that people are attracted to due to the obviously less charge, greater safety, and less regulatory.
Now, on the flip side, one of the things we're seeing because of the strong economy in the industrial sector, 2017 was a very strong year, and a lot of the industry players, manufacturers, contractors, and consultants, they're reporting that they have a lot of work on the books going into 2018. So, 2017 and going into 2018 is reported as being a really good year in the industrial sector. And across the board, we're seeing investment in upgrading of facilities and the building of new facilities for food manufacture and processing and handling. So this is where the discrepancy lies that we're talking about, this very strong year for the industrial sector, at the same time that the food retail sector have really scaled back on their spending. Now, the other thing I've noted in this article is that 2017 was also a really exciting time when it comes to the technology being used in these various sectors. And one of the examples we can give is the use of transcritical CO2 rack technology, which has been developed for the food retail market, but we're now seeing it being scaled up for use in industrial applications. So that's something that's really interesting, and it's a trend that we will be keeping an eye on throughout 2018.
Right. It's a comparison of low charge ammonia and no charge ammonia being carbon dioxide. So that'll be interesting. And of course, we're seeing some crossover, as you say, crossover of transcritical CO2 from the supermarket side to the industrial side, and then similarly crossover of low charge ammonia in the form of ammonia CO2 crossing from industrial over to supermarket.
Yeah, Michael, I don't know if I'd say that the advent of low charge ammonia has really been driving spending, but certainly this is a technology which is causing a bit of a buzz in the industrial market. And, I say it might not be driving spending because, I do think that these end users would be investing in their refrigeration equipment anyway. What low charge does is give them another option, and as you rightly say, an option which in some cases will attract less of a regulatory burden depending on the systems they have in use already, and of course there's the enhanced safety that comes along with a lower ammonia charge, and more coming into this debate as well. We're talking about the fact that low charge ammonia systems are often easier to service, so the service and maintenance of these systems is simplified, and that can help to ease the burden on refrigeration technicians, and this is something that could help to solve the ongoing challenge the industry has relating to the availability of trained maintenance staff for ammonia systems. Now, the other thing the advent of low charge ammonia is doing is allowing ammonia to be considered for applications where it would not normally be considered. So for example, a low charge ammonia system can be used in a food retail setting as the high side of a cascade system, perhaps with a pumped secondary CO2 on the low side, or some other configuration of CO2 which is distributed throughout the store. Now, what we know is that this type of system with an ammonia high side can be used in a very safe manner in a food retail environment, and this is driven by the fact that the amount of ammonia being used is relatively small, and so the risk associated is very low. And added to that, the ammonia is contained within one particular space, generally either a machinery room or on the roof of the building if package systems are being used. Now, in talking about package systems, this move to low charge and to packaged ammonia systems is also leading to ammonia being considered more and more for HVAC type applications. And while I don't see that we'll see very small scale HVAC from ammonia, although I would love to be proved wrong, range of something like 50 tons through to several hundred tons, perhaps 300 or 400 tons capacity, and that would be both in the air-cooled design and with water-cooled designs, and in all cases, of course, that would be minimizing the ammonia charge using the various low charge components and control strategies that are being developed at the moment.
Right. Yeah, we've written about many of these applications, like the Piggly Wiggly ammonia CO2 cascade system in their store in Georgia supermarket, and of course we just wrote about the Campbell Soup installation of the ammonia chiller for air conditioning purposes. Okay, so now let's talk about the 2018 predictions that were made by key stakeholders in the industry. And one of them is Pete Lepchat of Henningsen Cold Storage, which in fact is planning to install a CO2 transcritical system in a new plant this year, 2018. And Pete told me that he predicts increasing momentum towards CO2 systems, both subcritical and transcritical, and to a lesser extent towards low charge ammonia in new construction. Tristan Coffin of Whole Foods Market said that the needle has already begun to move on ejector technologies and advanced control strategies for CO2 transcritical. And he says that with the right design strategy, my hope is we can keep these systems from ever going transcritical as the ambient temperature rises. So, yeah, I think ejectors, which just made it an entrance into the North American marketplace in the last year or so, will continue to find installations in 2018, and that will continue to expand the map for transcritical CO2. What do you think?
Yeah, that's something we've seen. We've spoken a lot in 2017 about the use of ejectors in transcritical CO2 systems and that's talking about various architectures. But what we do know is that ejector technology can lead to significant efficiency improvements, and that this can help to push that CO2 border further south into warmer climates and really bring the efficiency of CO2 alongside or even better than some of the synthetic alternatives that are out there. And also what's quite exciting for me, and something that we touch on in a different article in this edition of Accelerate America, is the use of other associated energy efficiency technologies which can help to boost the efficiency of these systems even further. And one of the technologies that we mention in this month's edition is the SkyCool technology, which is essentially helping to reject heat into the upper atmosphere. And if you read that article, you can learn a bit more about it. But this is another technology which can be used really with any refrigeration system, but specifically when looking at transcritical CO2, it's another associated efficiency enhancement which can really help to make these systems attractive even in warmer climates. Another thing that I think is worth pointing out is that oftentimes with the move towards natural refrigerants and the move away from synthetic refrigerants, we see that companies who have their headquarters in Europe are often ahead of the game when it comes to setting a corporate strategy that moves them towards natural refrigerants. Now, obviously, for companies headquartered in Europe, that is driven by the fact that Europe are further ahead when it comes to the regulations which are phasing down HFCs and specifically talking there about the F-gas regulations. But when we see these European companies who have the experience in Europe then rolling out that strategy to their US-based operations ahead of time when it comes to the US phase out of HFCs, I think that's a very strong message, because here are companies who have the experience of refrigerant phase out in Europe. They have invested in new technology and they have tried and tested that technology, and they are happy enough with the results and comfortable enough with the technology that they're rolling it out to their US based operations before the regulations demand it. So I think that's a very interesting point to note, and again, something that we'll be keeping an eye on. The other point you mentioned there, Michael, is the comments that came from Pete Lepchat of Henningsen Cold Storage. And of course, we reported just last month on Henningsen's plans to install a transcritical CO2 system at their new refrigerated warehouse facility in Washington State. Now that's obviously a very exciting development. Henningsen Cold Storage, along with their contracting partner Permacold Engineering, they have really been pushing the envelope in terms of looking at a centralized ammonia system design, but really optimizing those ammonia systems to make them as efficient as possible with the lowest ammonia charge possible. So that's an example where they've stuck with a central plant design, but really optimized it through clever and deliberate design to minimize the ammonia charge. Now, with that experience, they've decided to try a transcritical CO2 package, and that's a very exciting development. What's interesting for me is that this is an installation that is in a relatively temperate climate. Washington, of course, has a fairly mild season for most of the year, although it does get pretty hot in summer. But having spoken to Pete, they do expect that this system will operate in subcritical mode for the majority of the year. And we'll be looking forward, as that installation progresses, we'll be looking forward to hearing more from Henningsen and from Permacold and from the manufacturer of the system as well, Carnot Refrigeration. We'll be excited to hear more about how this installation stacks up in terms of capital cost versus some of the alternatives that were considered. And once it's up and running next summer, we'll be looking to see how this system performs, and we can expect that Henningsen will be reporting on the energy performance of this building in the same way that they've done for some of their previous installations. So we'll be looking forward to reporting on that next year.
Yeah, it's going to be interesting. I'm sure we'll be talking to Pete later this year once that plant is up and running. And we also, in our predictions article, we heard from some other folks about CO2. Todd Ernest, who's CEO of a contractor called climate pros in the Chicago area. He said a few of his customers who were using some CO2 are making indications they may be moving into CO2 across the board very soon. So that's encouraging. Jeff Gingras, president of Systems LMP up in Canada, points out that Canadian market, in particular, perhaps even more than the U.S. market, has adapted these CO2 technologies. Many of his quotes for commercial and industrial are based on CO2. Also, Andre Patenaude of Emerson also pointed out Canadian supermarkets are moving ahead with transcritical CO2, and he said U.S. supermarkets with European ownership in particular, such as the Ahold Delhaize company, will continue to move forward with CO2 systems. Right, probably one of the best examples of that is Aldi, which has gotten a lot of experience in Europe with CO2 transcritical, and they're now the leading user of transcritical CO2 in the United States. We wrote about them in our September 2017 issue, and they're continuing to expand their rollout. A few other predictions I wanted to mention in terms of propane. Marek Ziglazinski of Embraco says that in 2018 he sees the growth of R290 applications in small size applications. That's because the bigger cabinets and so on are waiting for the charge limit to be increased. Of course, he's on the committee, the IEC committee, that's working on increasing that charge limit, and so we should see progress with the charge limit this year. And then Charlie Hahn of True points out that that his company is going to continue to increase its sales of R290. So that R290 will be certainly, it was big news last year, and it will be even bigger news this year, I think, as the rollouts continue. Yeah, A2L and A3 charge limits being looked at. In fact, that's actually one of the, going back to your piece, why the supermarket industry may not have been as robust in sales of refrigeration equipment, of natural refrigerant equipment, is actually because of that ruling that came down in August of 2017, which said that the EPA could not, as it has been, require companies to replace HFCs with the lower GWP refrigerants. But right now, it's on hold, and as we discussed, and we have to wait to see what the ultimate ruling is, and this will also be affected by the ratification of Kigali if and when that takes place.
Yep, that's a really good point, Michael. And one other point I'd like to highlight is we have a few comments here from Kurt Liebendorfer of Evapco, and he makes the good point that low charge ammonia will continue to develop into 2018, and he predicts a very strong year in terms of sales of low charge ammonia systems. But more importantly, on the regulatory front, and in terms of the guidance that the industry has available, Kurt mentions that we have already the IIAR are working on a low charge version of their ammonia refrigerant management guideline. So there's already a committee in place who've been meeting and developing a low charge version of the ARM guideline, and that will be welcome, as I know that the industry have flagged up a few questions relating to how they should be dealing with the design and installation of low charge systems. So that will bring some welcome clarity, and we'll look forward to seeing how that develops. Related to this, we're excited here at Sheco to be working on our Ammonia 21 World Guide to Low Charge Ammonia. And I've been working with my market development colleagues, and we have been reaching out to the industry, really looking in detail at the low charge ammonia industry around the world. And we've been looking at the technology that's being developed, the way this technology is being deployed, and the type of system designs that are coming onto the market. And more importantly, we're looking at the market for low charge ammonia, and the types of applications that are being considered for its deployment. So we're very excited to be working on this important guide. We will be releasing data towards the end of the first quarter, when I'll be presenting the initial findings from the guide in a workshop at the IIAR conference in Colorado Springs, and then we'll be presenting further data and publishing the full guide at our own Atmosphere America conference in June. So we're excited about that, and we look forward to sharing our findings with our listeners and readers.
Yeah, that sounds really great, Derek. Looking forward to that. But no question, low charge systems, whether they be packaged or central, will continue to make progress in 2018. So moving on, we'll discuss the AHR Expo that's going to take place next week in Chicago at McCormick Place, January 22nd to the 24th. We did a preview for our readers. The AHR Expo, of course, is one of the biggest trade shows in the world, certainly in the HVAC and R industry. It has over 2,000 exhibitors, over 100 educational sessions, and something like 65,000 attendees who are moving around several football fields worth of exhibits, and quite a few of them are with companies that market natural refrigerant products. When we talked about some of those in our piece on the CO2 side, we talked about Doran and Sandin. In fact, we talked about Sandin's heat pump, which we're going to discuss a little bit more in detail. Emerson will be featuring some CO2 products, as will Carell. Speaking of Carell, they're going to be featuring this EMJ modulating ejector that improves the efficiency of transcritical CO2 systems. It's interesting because last year Danfoss got a lot of attention for its ejector, and so it's good to have Carell showing its modulating ejector as well. I think as we talked about, ejectors going to be increasingly important part of the landscape.
Yeah, Michael, that's a good point. And as you've rightly said, the AHR Expo is a huge event taking place next week in Chicago at McCormick Place. And I think really you've written an excellent piece there in this month's magazine. And really what we're seeing, if you look at the trend year on year, is that we're seeing more exhibitors and more companies involved with the AHR Expo who are displaying and showcasing products that are either directly related to natural refrigerants or are supporting the deployment of natural refrigerants. So I think your summary there in the magazine is a really good way for our listeners to get to grips with what kind of natural refrigerant technology is on offer, and I would encourage everyone to take a look at that article.
And also we've got a great summary of some of the sessions that are relevant to natural refrigerants. And a few that jump out for me are certainly there's a transcritical CO2 condensing unit session. That's going to be the speaker there is Brandon Marshall of Carell Industries. So look out for that on the Monday afternoon. So that's certainly one that jumped out. Is there anything else that you would highlight, Michael, that our listeners should attend?
Right. Well, the hydrocarbons session that Arthur Miller does every year is definitely worth attending for people who are interested in using hydrocarbons as refrigerant.
Good point.
That's a very informative session.
Yeah, he'll be speaking on Monday morning and talking about hydrocarbons as an alternative to HFCs. So that's a very relevant discussion for our listeners. So yeah, that's a good point.
Yeah. In fact, for our listeners who will be attending the AHR Expo, we will be, as I mentioned, distributing print copies of the January issue. So you can refer to this article, this AHR Expo preview article, to get some ideas about exhibitors who have natural refrigerant products, and of course look at the different relevant sessions that you might want to attend while you're at AHR Expo. So I encourage our listeners to look for the magazine, and the magazine it'll be among the magazines in the magazine bins section of the show. But a couple of on the hydrocarbon side in this preview article, we talk about Embraco and EBM PAPs. Their fans assemblies are compatible with hydrocarbon refrigerants, and Carell also has a water loop system which can accommodate both CO2 and propane. So these are some other ideas for our listeners to consider if in terms of AHR Expo. Embraco is showcasing 2 hydrocarbon compressors and their plug-and cool, which is a propane condensing unit that they've been marketing the last few years. So, all right. Well, we're going to conclude this podcast with a talk about our cover story, which was very exciting for me to write because it's our very first cover story that talks about natural refrigerant applications at the household level, which regular consumers can use. We normally discuss what supermarkets are doing and industrial refrigeration operators are using, and of course that's where most of the natural refrigerant applications have taken place in the United States and Canada and Mexico so far. But what we're starting to see, as we have seen elsewhere in the world, is natural refrigerants being used in household appliances. For example, the Association of Home Appliance Manufacturers is expecting a transition in domestic refrigerators to hydrocarbons. They recently created a technician safety guide for just that trend, and the EPA has proposed raising the charge limit for propane in domestic refrigerators from 57 grams to 150 grams. So that's going to be an interesting trend to look at. But our article is about heat pumps. Sanden, which is a major Japanese manufacturer, is marketing a CO2-based domestic heat pump water heater. They introduced it in North America in August of 2016, and it's starting to draw some attention in the United States. And in particular, we talk in this article about what's going on in Seattle. The Sanden unit caught the eye of Charlie Rogers, who is the property rehabilitation specialist for the HomeWise weatherization program. and that's part of the City of Seattle's Office of Housing. HomeWise focuses on reducing the energy burden and utility costs for low-income households. And they determined that 24 low-rise townhomes in 6 buildings at the Qingwei apartments in Seattle were a good fit for the Sandin CO2 heat pump water heaters. And last year, over the course of the summer, I believe they installed these 24 water heaters, heat pump water heaters, replacing what had been electric resistance water heaters, which were much less efficient than the Sandin units. And in particular, Charlie said that Sandin was a good technology because of the heat recovery rate, meaning better heat recovery rate than say a heat pump using 410A. And that's really a function of CO2. CO2's thermodynamic properties, making it a very, very good refrigerant for generating hot water, and especially in a case like this where there is a lot of hot water usage in these particular apartments. According to Sandin, its CO2 heat pump water heaters' first hour rating, which is a reflection of its heat recovery, is the highest of all heat pump water heaters. Again, because of the ability of CO2 refrigerant to lift the water temperatures. So this is a very interesting application of CO2. We normally talk about it as a refrigerant creating cold. Here it's creating hot water. And again, it has unique characteristics that make it a very powerful refrigerant, for a heat pump. And I should have mentioned that Sandin, although this is new to the U.S., it's in Japan where Sandin is based. They have, this type of CO2 heat pump water heater is very popular. They sell 500,000, not just Sandin, but other companies, 500,000 units a year. So it's something that has, and it's also gotten some attention in Europe and Australia as well. So it's very exciting for the U.S. market to finally be exposed to this. And actually, my colleague Derek has a personal interest in this particular water heater. Isn't that right, Derek?
Yeah, that's right, Michael. We actually mentioned that in the magazine as well. I'm going to be installing one of these water heaters at my own home. We'll be doing that later this month. And, the reasons for me doing that are really much the same as the reasons that this has been chosen for this housing development. So for me, in the same way that we're seeing in this story, when I got this house, it had an old electric resistance water heater. So, we're using electricity directly to heat the water. And so, moving from an electrical resistance water heating system to any kind of heat pump is going to result in a large saving in the cost of creating hot water. And as we're rightly saying here in this story, the Sandin unit is the most efficient heat pump water heater on the market. And it's interesting, the very same properties of carbon dioxide that make it inefficient as a refrigerant when it's providing cooling and operating in transcritical mode. These very same properties are actually what leads to it being a very efficient water heating working fluid. And so we really take advantage of that by using the gas cooler portion of the transcritical CO2 circuit and using that to heat the water. A couple of other interesting design features of this heat pump that really attracted me to it. Some water heating heat pumps are installed on top of the water tank, and they may need fresh air from the outside to be ducted to the unit for the unit to work, if we're talking about an air source heat pump. In this particular case, what Sandon have done, and recognising that CO2 is not often very familiar to some of the installers that would be working in a domestic HVAC scenario, Sandon have decided to keep all of the CO2 within the factory built heat pump unit, and that unit is located outdoors. So the air source heat pump and the gas cooler are all located in the unit, and that's located outdoors. So the installer does not have to do anything with the CO2 circuit. It's fully assembled and pre-charged. What they do is they lay that unit outside the property, and then they run the cold water supply to the unit and the hot water return that goes back to the tank. And the Sandon heat pump itself has a small circulation pump that pumps the water around the loop that takes cold water from the tank and sends hot water back to the tank. So for me, that was a really interesting thing that I learned as I started researching the Sandon unit. Now, the second thing is that the unit is supplied with its own specially designed water tank. And it's, I think they say the tank has a 15-year warranty, which was another reason why I wanted to install this system at my own place, because it's a glass-lined stainless steel tank, so corrosion really is not an issue with that tank design. And another interesting thing is what Sandon do with their control system is that they rely on stratification of the hot and cold water in the tank. So what they'll do is they'll run the heat pump and they'll fill the tank with hot water, and that's drawing the coldest water from the bottom, heating it in the heat pump, and then sending it back to the top of the tank. And what they'll do is they'll fill the entire tank with hot water, and then they'll switch off the heat pump. And then what they do is they wait until the hot water is depleted from the tank before they start the heat pump again. And what this means is it can run at its most efficient point, always taking the coldest water from the tank. And also the what's key there is that the high first hour rating of the Sandon unit is really important there, because it can generate a lot of hot water in a relatively short time compared to other heat pumps. It just makes it really ideal for this type of application. So, for me personally, looking at my own home, I wanted a heat pump for my water heating, and I didn't want an HFC based heat pump, of course. So this was really an obvious option for me, and I'm looking forward to it being installed hopefully later this month.
Yeah, you should be able to save quite a bit on your electric bill. In fact, many of the reasons you stated are precisely the reasons that Charlie Rogers gave for selecting the Sandon unit for the Qingwei apartments in Seattle. But getting back to the energy efficiency, he actually said that he calculated, or he's estimated, that the 24 heat pump water heaters at these apartments will save 81,500 kilowatt hours per year compared to the previous electric resistance water heater. And that equates to about $300 per year savings to each family using the unit. And that's important particularly for low-income folks. He said that the energy factor for the Sandon unit is 2.9 compared to an energy factor of 1.0 for electric resistance units. So that means that Sandon should be using 1/3 as much energy. Obviously, a huge savings.
Yeah, and I calculated something similar looking at this, and this is actually something that's widely available to anyone who wants to do the research. But if you use an electric resistance water heater, as millions of homes in America do, then you're probably paying in the region of $3 for every 100 gallons of hot water. Now, for the Sandon unit, that number is much lower, and for any heat pump it's much lower. But Sandon promised that would be the lowest of anything on the market, and they're looking at something like 70 cents per 100 gallons of hot water. So that's it's actually more than it's less than 1/3 of the running cost, which is quite exciting.
Yeah. The one challenge that Charlie acknowledged to the system is its higher cost, and you'll be hearing from Charlie himself as part of this podcast. He said that the price of the sand unit was about $3,000, $5,500 with everything included, which is about twice that of a standard water heater, he said. But he added that in this application, with very large family sizes, so much hot water use, and much greater energy savings, he was able to justify the cost. So, of course, we're in very early days of this unit being sold in North America, and with greater volume, I would imagine the prices will decrease. But it certainly seems to be worth the investment at this point.
Yeah, I think so. I mean, I think the first cost is always going to be a challenge with this type of technology. And it was interesting, I sat in on a training session that Sandon were running for a local HVAC distributor based just north of here in Vancouver, Washington. And it was interesting to be there and to listen to some of the questions that come from the HVAC installers. And really, when you think about their business, they have a business where they want to be installing equipment, they want to go to their job site, they want to install the equipment, they want it to be running, and then they leave and they move on to the next job. And if anything does go wrong with the equipment, they want to make sure that they have a warranty that covers at least the parts and perhaps their labour. So it's good to get a feel for Sandon are offering such a great warranty on this equipment, and it makes it attractive to the installers as well.
Okay, well, now we're going to hear from Charlie Rogers of the Seattle Housing Office talking with me about the installation of Sandon's CO2 heat pump water heater at the Qingwei Apartments in Seattle.
Well, there's two questions. Who decided to use these units as a replacement for the original, system?
Right.
And, who decided to do that, and who paid for it?
So I did this project was mine, so
Mm-hmm.
I did the inspection and identified the unique need.
Mm-hmm.
I saw the high household sizes, identified that there was a lot of hot water usage going on there, and there isn't previously, the heat pump water heaters that we've been working with, the R410A systems, they don't have a very high recovery rate.
Now, recovery rate, what does that mean exactly?
Just how quickly they reheat the water.
Right.
So how quickly they replenish the hot water in the tank.
Right.
And so if you don't have a very high recovery rate, you're going to run out of hot water.
Right.
And so if you have a 7 or 8 person household, it might still behave like a standard electric resistance water heater, or maybe a little bit worse. But I wanted something that was really going to, without a question, provide hot water when the occupants needed it. I didn't want to put in a new water heater and have them have less water.
Right.
The other thing I was looking at is we couldn't really put in the standard heat pump water heater in these townhomes because the tanks were in a small closet underneath a second floor stairway. And all of the systems that are out there, not including the Sandon unit, have the compressor on the top of the tank.
Mm.
And so they're stealing energy from the air outside of the tank, and they need a certain volume of air to operate to the manufacturer's standards. So if you put it in a small closet, you have to put a jumper duct or a passive grill through the wall or something to bring more air into that room. And it just gets a little bit more complicated. It's doable, but it's not as easy. And then the other thing too is that your compressor's inside, so it's making noise. So that presents some issues.
Okay, so you chose the equipment, and the owner took advantage of this program to upgrade, basically cost-free upgrade, that will reduce the energy costs for
the tenants.
Ultimately for the I mean for the building and thus for the tenants who are paying the bill, right?
Yeah,
So
I mean, I think.
Do you know how much that's happened? You know, how much reduction they've seen to date?
I haven't checked the bills, and I wouldn't trust them at this point because it's been such a short period of time.
Right.
And
But your expectation is, I mean, based on the efficiency, that's the modeling part, right?
Yeah, the estimated savings from the 24 heat pumps was about 80,000 kilowatt hours a year, which is high, but there's high household sizes there, so you've got a lot of hot water units.
Do you know how much of a percentage difference that is from the?
I can't remember off the top of my head. I can go back and look at my model. But the Sandin, I was modeling it with an energy factor of 2.9. So roughly speaking, that's about the Sandin should be using about a third of the electricity that the electric resistance meters were consuming.
Yeah, I mean, that's substantial, right? I mean, that's a substantial difference.
Huge.
Yeah.
Some other benefits to the Sandin unit that made me feel really comfortable about installing it. One is all the refrigerant lines are self-contained in the outdoor unit, so there's much lower risk for installer error. They're not running line sets. They're not flaring connections. So I think the system should be more durable and have less maintenance issues.
Yeah, the only thing that's flowing is the water, right?
Exactly.
Yeah.
Yeah, or your electric hookup, but yeah.
And electric, yeah.
Yeah. So that's really nice. And like we were talking about the energy costs, all the energy savings is going to the tenants. So their bills being reduced. The owner's not seeing that, but what the owner is getting is lowered maintenance. Because the maintenance staff are having to change out those elements regularly.
You mean in a regular
electric resistance?
Electric resistance. Oh, okay, right.
And the tanks are a lot more durable. Part of that's because the Sandin tanks are, I think they're like glass-lined steel, stainless steel. I don't know why you need to line the stainless steel with glass, but get that extra protection. And there's no elements in the tank. It's just a storage tank, so you don't have the wear and tear that associated with it. And
so there'd be less maintenance than for an electric water heater, yeah, because it doesn't have electric water heater has those elements.
Yeah. Okay.
What are the challenges that you've seen in this?
The higher cost of the system.
Yeah.
At this project, we paid $5,500 a unit. That's everything included, and that's a lot. That's a lot of money, and that's a lot more than we've paid for heat pump, other kinds of heat pump water heaters. It's more than
what they would have paid or what they'd paid for a new electric, the same electric unit. Yeah.
Yeah, I think you can expect to pay just for the materials for a standard heat pump water heater. I think they're around $1,500, and I think the stand-ins were around $3,000.
Mm-hmm.
So the cost is considerably higher. But in this application where we had large family sizes, we were able to justify the additional cost because there was so much hot water use, and so the savings was that much greater.
Right, in terms of the energy savings.
Yeah.
Yeah, and the money saved through energy reduction.
Yeah.
Thanks, Charlie. Well, that will do it for this month's podcast. I'd like to thank my colleague Derek Hamilton, as well as Charlie Rogers of the City of Seattle. And thanks to our listeners. We'll see you next month on the Accelerate America podcast.